Hello and welcome to today's Cul-de-Sac design session. Today's presenter is Martin Ramirez from Jacobs. He's a design engineer with 4 years of experience, graduated from Iowa State in 2017 with his degree in civil engineering. Throughout his career, he's used Civil 3D extensively on a wide range of projects, from smaller municipal reconstruction projects to large tollway and high-speed rail projects around the country. The objectives for today's workshop are learning how to drain a cul-de-sac to a specific location and elevation, develop a workflow for cul-de-sacs that is simple to update, and to be able to add a crown to a cul-de-sac and control the drainage on both sides. With that, I'll hand it over to Martin to get today's session going.
Hello everyone, welcome to my cul-de-sac design workshop. Today I'll be showing you a way to ensure that you always have the proper drainage in a cul-de-sac, and a very easy way for you to determine your profiles along your flange. I guess the reason that you might want to do this is because sometimes you're bound to where the water has to go. So I can show you an example of what I mean by that. This is a project that I was working on in Las Vegas, and to all of you that have been there, the airport is roughly in this area. So in this project we have Tropicana, which is running from left to right, and that's going to be reconstructed, and in part of it we're adding this turnaround here, this cul-de-sac, and we're limited by what's already there in terms of utilities. If I remember correctly, this was a gas line and then this was a sanitary sewer, and we were adding storm sewer, but we had to hit some very specific elevations and just trying to avoid all these other utilities that were in there. And to start off with, I'll show you what I have here on the screen and then we can go from there. So we have a very basic layout with a cul-de-sac, an offset cul-de-sac, and then I've already started designing part of the corridor, and then going further to the right we have some assemblies. This is for the throat of the cul-de-sac, and then this is for the actual cul-de-sac. Further to the right we have two profiles, one for the center line and then one for the flange at the cul-de-sac. I also cut a cross section in there that we can slide along the alignment so we can make sure that everything is working out in terms of the grades. Okay, so before we get started, I guess I should mention that it's very difficult to get this all in one take, not because this is a difficult method, but because I forget little things here and there. So you might notice little changes from 1 second to the next, and that's because I restarted part of the recording. But none of the changes I ever do are big. It's just maybe taking a couple steps back so I make sure that I explain everything correctly. So like I was saying, we're going to be designing first the planar cul-de-sac and then a crowned one. And for the thing I have modeled down here already, the throat of the cul-de-sac, I'm showing below the cross section, and as you can see, everything is straining to the left because eventually we want to get it to this structure with this spot elevation, or not spot elevation but target elevation. And the first step in designing this cul-de-sac is to get some guides for us, and those will be spot elevations. So we'll go to surface, spot elevation. We'll just leave the default for now. And then for the surface, we'll select the EG for now, but we'll be changing that here in a second. We'll put one at the inlet, and then we'll put one at the center of the cul-de-sac. Make sure that's at the center. Okay. Okay, so the first thing we want to do is we want to create a feature line that is tangent at the inlet, and we'll be creating from that feature line. And how I do that is that I create an arc, and then from there I can create a line, a line that is tangent from a point. I'll select that arc and that point. And what I want to do with this line is I want to cover the whole cul-de-sac. So going to the north, it looks like about 80 feet should do it, so I'll type in 80. And then going south, I'll hit lengthen. And I want to make sure I cover this corner. So it looks like 80 feet will do it again, but I'll type in 90 just to make sure. And I'll go ahead and I'll turn this into a feature line. So I'll select feature line from objects, hit enter, and for the site, I'll put it in site number 1, and make sure you hit assign elevations. And the elevation that I want here is what I want the structure inlet to be at. So that was 1151.60, and hit OK. So what this feature line represents is what we'll be grading from for the rest of the cul-de-sac. So then slowly we'll be going from 1151.60 to whatever elevation we need over here. First off, I'll delete this, we don't need it anymore. And I'll go ahead and grade. So I'll go to grading creation tools. I'll hit this first button. For the grading group, I'll just type in the name or the elevation that we're trying to hit. And make sure you hit the automatic surface creation. If you forget to do this, you can always just create a surface and add the feature lines that we'll be having here to that surface definition. So I'll hit OK. It'll ask me about the surface, and I'll just leave it no display so that it's not cluttering up the space here, and I'll hit OK. Next up, make sure to select grade to distance, and I'll create the grading. So for the side, I want to grade towards the cul-de-sac the entire length, and I want to cover the whole cul-de-sac. Looks like 100 should do it. I'll type in 120 just to make sure. Grade. And then this is the percent that you want to grade out to. For this example, I'll be using 2%. That's pretty standard. Okay. So now we have a grading which is automatically being turned into a surface. And this surface will allow us to obtain our cul-de-sac profile. The next thing I want to do is I want to switch these two guides into a reference of the new surface we have. So I'll go from EG to that one. And as you can see, this number should match that one, and then this number should be higher than this one. So right now everything seems to be going well. The next thing we'll do is that we will be sampling this new surface along the flange. So I will go ahead and show the profile right here. So this is the flange, and right now we have this surface sampled, and that is for this model. So as you can see at the start of the flange, we have this elevation here, then we wrap around, we don't hit anything, and then on this side we hit this elevation, so it should be this one. So I'll go ahead and sample the new surface we created, which was from the grading along the flange. Okay, so I'll select flange, and then I'll select the surface. I'll go ahead and select basic for now. I'll hit OK, and then I'll hit OK. And this is what we have here. And as you can see, it looks like it's going towards a low point at this location. So we can check really quick and make sure that this is making sense. So this is at about 151.25, I would say. So we have 150, 151, 152. So roughly it looks like it's going to the correct location, just as a sanity check. So now we have what we could use as our profile for the flange. but we want to make sure that the cul-de-sac merges into what we have modeled already, and that it does so in a smooth way. So for the transition, I'll be using just this geometry point of where this curve switches locations, or sorry, directions. And then on this side, I'll just be using 153. I'll go ahead and put some markers real quick. Okay, and that one. And I want to obtain the station of that location, so I'll go to annotate, alignment, station. I'll put one right there. And that's a little hard to see, so we'll go ahead and change its style to hopefully that one. Okay. So we will need to mark out 38.27 and 153. And I already went ahead and did that. So this is where we need to tie in. That's where we need to tie in. So the next step will be to create a profile that will take us from this elevation, which should be this point, to this elevation from the graded surface. The graded surface will take us around the cul-de-sac, and then we'll need one from that surface back to what we already have. So I'll go ahead and create that. And I'll go ahead and name this PR for proposed. I won't need any labels for now. Okay, and I'll be drawing the tangents. And I'll start at this point just so that I make sure that the corridor always has something to read from. Okay. So like I was saying before, right now we're connecting this point to that point, so that will be this point to this point. In the middle, we won't need anything for now. We just need this point to this point. So that should be from right here to right here. And like I did on the other side, I'll go a little bit further, hit enter. Okay. And I'll change the style for this real quick just so that we can see a difference between the proposed and that one. Maybe basic will do it. Let's try standard. We'll try one more. Oh, that made it go away. Right. Well, it looks like all the styles we have look the same, so I'll just go back to basic. Okay, so now what we have is that the flange will be able to read along from this transition. It'll be reading our profile that we just created. From this point to this point, it will be using the graded surface. And then from this point to this point, it'll again switch to our profile. The next thing I want to do is I want to switch the center of the cul-de-sac, its profile, to match that point. Okay, so we'll select it. This changed. So we'll be able to select and type in an elevation, and that was 1152.6. So I'll go ahead and type that here, 1152.6. Okay. So what that point is that along this surface, which is 2% from this point that we're trying to hit, it's grading up at 2%, and we know that at the center of the cul-de-sac it has to be 1152.6. And since this is the profile for this alignment, at the center we need to make sure that it's that same elevation. And just to be sure, actually, I'll extend this a little bit further, because sometimes the corridor, if you put it at the exact point, the corridor for some reason misses it. So I'll go ahead and just add a little bit to that. Okay, so now we'll add that part to the model we already have started here, and we have the sub-assemblies for that right here. So I'll go ahead and let me make sure that I actually name this profile that we sampled something that would make sense. Okay, so its name was just surface 76, so I'll name it setup and 1151.60, which was our target inlet. Okay, so now we should be good to go. And I had already done some of this before, just to save us some time. So this first section right here, this first section will take us from here to here. So right there we'll be needing to use our profile, which was this one, the flange proposed. And then this one will take us from here all the way around. So we'll be using that setup that we just renamed. And then this one will complete the cul-de-sac and take us from here to here. So I'll switch back to the flange PR. Okay, make sure our targets are correct. I'll just go ahead and put that for there. So at the cul-de-sac it's very easy. We're always targeting the same alignment, center line. For the elevation, we want to target that center line PR. And then this is the one that we made sure we had the same elevation as the center spot elevation. So we'll go ahead and do that. Hit OK. We have 2 more to do that for. Okay. Hit OK. And one last one. EG. So this is for the daylight, the slope intercept outside of the cul-de-sac. So I'll add center line and the proposed profile. Okay. Just want to make sure everything looks right. Center line, proposed. Make sure there's no EGs in there. Go ahead and hit OK and rebuild the corridor. Okay. So now we can take a look at what we have here, and over here I'll switch over to our section. This is the sample line that this section is being cut from, and it should be dynamic if we slide back and forth. Okay. So as we come to the cul-de-sac, you can see everything is straining to the left. We want to make sure that everything keeps straining that way. Okay. And what's going on here? Let's keep going. Okay, so it looks like this is missing part of the model, but we'll make sure that everything's looking right based on the surface. So we'll just slide this to a location that doesn't look as scary as over here. Okay, so we'll go ahead and create the surface. I have everything added in here. We'll go ahead and select base course triangle, something that we can see a 3D model of. Hit OK. And then we'll look at the 3D model of this. Okay, so it looks like there is a problem at the center, and I suspect it's that I did not hold the center line profile far enough. So we'll go ahead, or let me make sure that we have the correct elevation, 1152.60. $52.60. Okay. I'll go ahead and pull this to this spot and rebuild the corridor. So let's take a look at that one more time. Okay, that got rid of our little spot there. And as you can see, this looks very smooth and everything looks clean. So now we'll take a look at the contours and make sure everything is draining to the correct location. So for that, I'll go ahead and maximize this screen. Select our surface, and we'll select a style that will show us what's going on here. And as you can see, everything seems to be looking right in terms of these contours. I'll go ahead and edit these contours so that we have maybe a little bit more of them. Contours, intervals, 10.1, hit OK, hit OK. Okay, so as you can see, everything is draining this way, and then everything continues to drain to this location. One more thing we can do is we can add a couple of slope labels. So we'll go to slope, we'll select that surface, and I'll do 1 point, and I'll place a couple of these just throughout. And as you can see, we hit exactly 2% just about everywhere. One last thing I can do is that I can select the style that maybe will show us the arrows. Maybe this one will do it. Okay. So as you can see, all these arrows point to this location. And one last check we can do, if I go back to something that will clean this up a bit, is that if I select the surface, I can place a couple of water drops. They should all be going right to our inlet. Maybe I can place one over here. And as you can see, they all end up right at the inlet, right where we need it to be. And so what this allowed us to do is that we selected a low point, graded out at 2%, and on the profiles we matched up to the throat of the cul-de-sac, and then in the end we were able to come out with a planar cul-de-sac where we ensure that all the drainage is going to the correct location. Okay, so how could we finalize our design? What we can do is over here, instead of having our profile that cuts from our transition and in the middle where the profile is basically useless, then the transition, instead of having this section here, what we can do is we can go ahead and trace out the setup profile and have a nice profile for construction. And it doesn't matter if it's not 100% following what we have here, as long as it follows the overall trajectory of this profile, then we should be able to have the drainage that we designed for. And like I was saying before, this feature line, since it controls the setup surface, it makes the whole thing very dynamic. So what I can do right now is I can go ahead and change the low point elevation, and we should be able to update everything really quick. So let's say we wanted to redesign everything for, instead of 1151.6, if we went to 7.5. Okay, so what we would have to do is, first off, we would have to turn off the cul-de-sac part because we're gonna have to redo the transition. So we'll rebuild the corridor. Okay, this will clean up the transitions over here. And what we will do is also adjust this feature line, which controls the setup surface. So we'll switch these things, or these elevations, to 1151.75. Hit OK. And this surface is automatic, and so is the grading, so we already have the update shown over here. All we have to do is adjust right here, which is where the setup surface starts. And we'll go ahead and adjust this location. I guess before I do this part, I'll make sure that this spot elevation was also updated, so I'll make sure that this changes as well. Okay, so now instead of 0.6, we want to hit 0.75. So we'll hit 75. And this number doesn't have to be exact. As long as it's very close, you'll get the proper drainage. Okay, so we have that number there. This changed a bit. I'll rerun the corridor. And the reason I reran the corridor is because these should change. And if you notice, I changed the color of the profile so that it's different from what we have as our design. Okay, so now we will connect to it, transition, connect to our setup surface, and connect to our setup surface, and once again transition. Okay, that looks like it was already at the correct location. And now we have updated our inlet elevation, so I'll go ahead and recreate the corridor cul-de-sac. All the targets should stay the same. I'll hit rebuild, and once again everything is going 2% to that same spot, but this time it's a little bit higher than before. And then this is very easy. For example, if I wanted to switch the grade of this, what I can do is I can go ahead and edit this grading. So let's see how quick that will be. So grading creation tools, we'll go ahead and edit grading. So the distance, we'll keep it at 120, grade 3%. I'll hit enter. And then I will turn off the part of the corridor that we don't need. Okay, so now we're grading from 1151.75. We have to hit this elevation at the center, so I'll go ahead and also change this one. Wrong button. Geometry editor, and this one. And that is 1153.25. I'll rebuild the corridor so that we have the locations we're tying into also be updated. Okay. And now we'll just reconnect everything. So we should be able to do that. And then on this side. And as you can see on this side, we're starting to have a problem with some of the grades. What's going to be happening here is that there will be a low point created on this side over here where the water will want to drain to this location. because 3% will put us higher than this point. And there's a couple of ways we can fix that. Either we can adjust this elevation, go lower. Maybe at this point you realize that 3% is maybe not the correct choice, or maybe we want to increase or increase the elevation of this profile along the throat of the cul-de-sac. Maybe the cross slope might need to change a little bit from having a 2% going this way, maybe something a little bit higher. But once I reconnect everything, what I can do is I'll turn everything back on. And rebuild. And so that we can take a look at our contours, I'll select the surface and I'll switch over to that one. Okay. And as you can see, we have a problem now, and that is where we have this low point here, which was our target, and like I was saying before, we're creating a problem where we're creating a second low point, and this is where maybe having a crown on your cul-de-sac is useful. So I'll switch over to that file and we'll get going on that. Okay, so picking up where we left off, we'll be adding a crown to this cul-de-sac, and once again the reason is because when we looked at the transition, we could see that there was a low point being created before the inlet that we're trying to target, which is somewhere over here. So what I'll do now is, if we're going to add a crown, might as well crown the throat of the cul-de-sac. So we'll add the crown back, and if I redo the corridor, you will see that there will be a jagged piece created here, and that's because now the transition, which was transitioning higher at this point, has to now come down, because it's now going down at 2% instead of up. But what I'm going to do is I'll be turning off the cul-de-sac, and then I will turn off the, or actually I was going to turn off the corridor, but now this looks pretty clean. And what we will do now is we'll select an arbitrary inlet somewhere over here, just put it right there for now, and we will also give it an arbitrary elevation just for this example. We'll select, we can try 1152. I'll move this over. Okay, so now we know what the other inlet we're trying to hit, and this might arise in situations where maybe we already have driveways and you have a specific spot you're trying to put an inlet at. Maybe you don't want the water to wrap all the way around so that it collects at a single point, and it might be necessary for you to select a specific target. So I'll also go ahead and copy this spot elevation over for future purposes. And the next step would be to select what part of this cul-de-sac you would like to drain in this direction. So I will pick arbitrarily just this point. I'll pick right there, so to the center, and then I have to trace out the ridge line of the area that I want to drain this way, and then the other area will drain this way. So I will do this with a polyline and do that. Okay, so now we know this area wants to drain this way, this area wants to drain this way. And we can't do what we did before, where we just created a perpendicular feature line and created it this way. And the reason is because we want the direction of this setup surface that we'll be creating to go this way. And the thing is that we want it to connect to the ridge line so that it drains always in the direction of this inlet. So what we will do for that, and to backtrack a bit, we can't do a feature line perpendicular to this point, also because we're no longer just bound by this side, we're also bound by this side. We want to connect along this ridge line. So I hope that makes sense. I wish I could have done a little better job of explaining that, but in the end, we want to connect to this ridge line and then work our way back to this location. So we will create a line that is at 1152 like before, but we now know where it has to hit on this side. Okay, so just like we did before, we'll do that. We'll select this point and this point. Okay, create a line tangent from a point. And now we have to cover not the whole cul-de-sac, but at least our slice that's draining this way. Looks like 60 will do it. And then on this side, it looks like 110 should do it. Okay. So now we will create a feature line for this line. Feature line from objects. And for the site, make sure you select the site that's different as the previous setup surface. So I'll create a whole nother site for this, name it site 2. And for this elevation, we want, 1152. Hit OK. So now we have this side, and now we will need this side, which is the ridge line. And for that, what we will be using is we'll be using this setup surface that we had before. So feature line from objects, site 2, OK. And from surface, and if you remember this graded surface, we had given it this name. So we'll do that. And you will select not to insert intermediate grade points or grade breakpoints because we want a smooth line from here to here. So we'll hit OK. And the reason we select not to put it in the same site is because what will happen if you put it in the same site is that it will override whatever you have on that same site. So like let's say you had a feature line that was at elevation 0 and then you crossed it with another feature line in the same site with elevation 5. What it will do is it will override where it intercepts, and we don't want it to do that in this situation. Okay, so now we have this feature line and this feature line. This looks like a feature line, but it's a sample line for this for the section we had, so I'll move that out of the way. And now we need to create a corridor, and I'll explain that in a second. But for this corridor, we'll go ahead and select create assembly. We'll just name it setup for now. And the subassembly we will need for this one is width and slope, and I'll explain that here in a second. What we will be doing is we'll be creating a corridor that connects this line to this line, and we selected width and slope because this will be our baseline, this will be our width, and this feature line's elevation will also be the end of our subassembly elevation. Okay, so now we have that. We'll go ahead and create that setup corridor. We'll just name this setup. Feature line for our baseline, we'll select this one and setup. Hit OK. And we have to make sure that it covers our whole slice that we wanted to transition from. So we'll select this. And if you notice, it won't cover this little spot right here, but that's okay because we'll have a transition anyways. Okay, and then at the top area, we'll go to right there. And really quickly, I will select our targets. Once again, we're doing feature line because our target will be this ridge line. Hit enter. Hit enter. Okay, for frequency, we'll just type in 5. And we'll hit OK. Okay, so now we have our setup surface that we can now sample at the flange, but first we need to actually create the surface for this. So we'll do this, create surface, we'll name it setup, second half. We'll add a boundary to this, top links, and we'll just leave everything else as is. Rebuild the corridor. And now we can sample that new surface along the flange. And so what we should see is we should see this going down to this point, going up, and then in this location, once again, going down to this point and coming back up. So we will split our screen in two so we can look at both at the same time, two horizontal. So we'll have that in frame. And here we go. So once again, we should see another dip here. So profile, create surface profile. Second half. Select basic. Hit OK. Okay, so we are seeing a low point created at about 11:52:50. Sorry, 1:52:50. So 1:52:50. This seems to be right, but we'll make sure of that in a second. So now what we want to do is we want to identify that transition where we want to transition like we did before, somewhere right here. So we can select 153, maybe 40. Okay, so we have 153. We will offset this 40. Okay, so now our transition will be that location to there. And once again, this is just so that the profile always covers an area that we will need. Okay, so looking at this, what will happen is that starting at this location, we will tie in to what we have modeled here already. Then we will transition with our profile to this point. Then we will use our first setup surface up to this point, which should be this point. And then we will switch over to this new surface we created into our transition, which is at 153.40, roughly right here, and then we will transition. Okay, so I'll turn off this corridor so it's not in the way. Okay. And so looking at this area is still valid, so that should be this one. Now this one changed because before it wrapped all the way around to the next transition, but now it needs to end a little bit before, which should be right there. 151.96. We'll turn that on. We'll add a baseline. Once again, the flange. But this time, so this is our proposed one, which we are using for our transitions. This is our first setup one. And I forgot to name this one something that would make sense, but we know it's the only other one. Surface 78. And this one, we will add a region, CDS. So this one will follow after this one. So it will be 151 plus 96. And this will go all the way to our transition, which was 153.40. 153.40. We'll give it a target. And this part is just like we did in the first section of this workshop, which was for a planar cul-de-sac proposed. And so this should be our transition, which was 153 plus 40. And this should stay the same because our transition point is the same, but we can make sure, just click somewhere right there. Yep. And just to make everything even, everything else is at 5, so we'll go ahead and type in 5 here. And we will rebuild this. Okay. So let's look at its surface. So I'll turn off the corridor just so that everything is easier to see. So as you can see, we have a crown now. With this crown, this part of the crown coming to this location. And we will make sure that this is at the correct elevation. It's reading from our setup surface, so now we will read off of our model. So yep, 152. So as you can see, the crown on this location goes this way. In this location it goes this way. What we can also do is turn on the arrows. So you can see these arrows point this way, right where we created our ridge line. We want them to go this way. We'll add a couple of water drops. So you can see they're all flowing to the correct location. And then on this side, they're flowing to that location. And as a last check, what we can do is we can set up a 3D surface style so that we can look at this. Okay, looks pretty good. And looks pretty good. You can see we have a faint crown. Maybe with this one you can see it a little bit better. As you can see, we now have a crown with this area draining this way. And so now we can control exactly where the water goes for a crown cul-de-sac, and we can hit a specific inlet at a specific elevation. And I had the contour showing up very frequent, but with this one showing 2-foot major contours, 1/2-foot minors, looks a little bit better. And as you can see, we have this section going this way, this one going this way.
So now to summarize, some of the objectives we had for this workshop were that we wanted to be able to drain a cul-de-sac to a specific location and a specific elevation. We also wanted to develop a workflow that worked for cul-de-sacs that was simple and that would always result in proper drainage. We also wanted to be able to add a crown to a cul-de-sac and control both sides of the cul-de-sac, and that is in terms of targeting the location and elevation. Some of the methods that we used in order to achieve these objectives were that we set up temporary setup surfaces for the flange profiles. We also created transitions between our cul-de-sac design and an existing feature, an existing roadway, or a previously designed roadway. We also set up some dynamic labels that helped us obtain some of the design parameters and that we also used as checks. So for example, the spot elevations we placed and some of the grade labels we placed. We also set up secondary setup surfaces for the crown cul-de-sac. And finally, we took a look very briefly at some of the surface styles that we could use in order to make sure everything was draining properly. So for example, the arrow surface style, or just adding more contours. And this is an example of where this workshop would come in handy. As you can see here, we have a cul-de-sac that seems to be having some drainage issues, but it's also tied up by the fact that we already have some driveways, we have an inlet that's already existing there, and if we wanted to rebuild this cul-de-sac, we would have to make sure that everything was being directed to this inlet and that none of the water was going to maybe some of these driveways. Okay, so moving forward, you should be able to come up with a cul-de-sac design that is consistent in terms of the cross slope and that drains properly. You should also have better control over the placement of inlets now that you know you can direct water and target these specific features. You should no longer have to be going through minor adjustments, and making this an iterative process is no longer needed now that you know how to get to a specific design in a linear fashion. It's no longer a guess and check process. Updates should also be a lot quicker now that you know how to handle those. And some sources that I used for this workshop were Scott Hunnicky at WHKS and Company, and he's an engineer I worked with back in Minnesota. I also used Cindy Davenport's blog, trulycindy3d.com, and even though it seems to not be getting updated anymore, what she already has on there is pretty useful. And then I also relied on a lot of my Jacobs co-workers, and that has been my workshop for cul-de-sac design. Thank you.